In this video, I'm going to talk about one of the ways that we can classify different types of chemical reactions. And this is based on the schemes of the chemical reactions that we see. The first one is called combination, where two or more elements or compounds combine to form one product. So two or more things becoming one thing. And decomposition, which is essentially just the opposite of that, where a single reactant breaks down into two or more products. Then we can have single replacement, so an uncombined element takes the place of an element in a compound. Double replacement, the ions of the reactant compound switch places. And combustion, where a compound reacts with oxygen to produce carbon dioxide and water. And so we'll look at each of these in a little bit more detail here. The first one was the combination reaction, where two or more elements or compounds combine to form one product. So we have something like A here plus X becoming AX. So that would look something kind of like this, where we have the purple one here plus the green one here combining to form this compound here. So a few examples for this, we can have something like magnesium and oxygen coming together to form magnesium oxide. Or we can have something like copper and sulfur coming together to form copper sulfide. And so if you want to try and work on this one here, pause the video and work on it before I show the answer. So we're bringing nitrogen gas and hydrogen gas together, and when we do that, we will form ammonia. And so we need to put a 3 in front of the hydrogen, and then we get 2 ammonia from this. So again, we're taking two or more things and bringing them together to make one thing. And when I say two or more and one, what I mean is the types of things. So we see we can have more than one thing here. So we have 3 hydrogens, but we only have 2 types of things. So 1 nitrogen and 1 hydrogen right here. The next one is the decomposition. This is when a single reactant breaks down into 2 or more products. The general scheme for that is AX becoming A plus X. So that would look something like this. It's basically the reverse of the combination. And so we take this purple and this green thing bound together. We break them apart into the single purple and the single green thing. So a few examples here. We can have this mercury 2 oxide that breaks down into mercury and oxygen. Or we can have something like this calcium carbonate breaking down into calcium oxide plus carbon dioxide. And this is actually a very important reaction in a lot of modern day things. This is an important one for making cement. It's called calcination, and it produces a lot of carbon dioxide. But anyway, that is an example of a decomposition reaction. And so again, I would encourage you to pause the video, try balancing and coming up with the products for this reaction. And so we have HCl gas, and that's going to break down and become hydrogen gas and chlorine gas. And we would need 2 of the HCl for this. The next one is single replacement. Uncombined element, a substance in its elemental form, takes the place of an element in a compound. The general scheme is we have some compound AB, and then we bring in some element X, and then X will take the place of B in this case. It could also take the place of A in some cases, but as long as it's taking the place of one of the things in the compound. So that would look something like this, where we have this compound of the purple and green balls here, plus we have the blue one here that's by itself. The blue one takes the place of the green one. So some examples for this, if we have aluminum plus HCl, the aluminum will bind with the chloride here, then the hydrogen gets left out. So the aluminum is taking the place of the hydrogen in this case. Or we can have something like this, where the chlorine will now be taking place of the bromide in this reaction. So the bromide is going to get left out in the elemental form here, where the elemental chlorine will take its place and become potassium chloride. Again, I encourage you to pause the video and try this one on your own. So here we have zinc plus hydrobromic acid. And so the zinc, because we know it's positively charged, is going to take the place of the positively charged hydrogen. And so we would end up with zinc bromide plus hydrogen gas in this case. The next one, we have double replacement, so the ions in the reacting compounds just switch places. So if we start with AB, this compound AB, plus this compound XY, the Y and B will switch places so that we end up with AY plus BX. So that looks like this, where this green and this yellow ion here are switching places. So the yellow one ends up on the purple one, and the green one ends up on the blue one there. So a few examples, if we have this sodium hydroxide plus hydrochloric acid, these react, and so we end up with sodium chloride plus water right here. And I drew the water like this, HOH rather than H2O, just to show that that hydrogen is ending up there. In the next example, we have aluminum sulfate plus potassium hydroxide. Again, this hydroxide here will be going to the aluminum, the sulfate here will be going to the potassium, so that we end up with aluminum hydroxide and potassium sulfate. And so one thing to notice in these reactions is these are all ionic compounds. So we are always just switching ions between the two compounds in the reactants. And another thing to notice, and this is something that happens quite often in these reactions, one of the products ends up being a solid. We'll talk more about that in future videos when we get to solubility, but this is called a precipitation reaction, where we're forming a solid out of previously only aqueous things. So again, I would encourage you, pause the video, try this one on your own. And so the products here will be the sodium chloride and the barium sulfate, where we see the sulfate is going to the barium, the chlorides are going to the sodium, and so those are all switching places. The last one here, and I'm going to talk a bit more about this in quite a bit more detail in the next video, but these are combustion reactions. So a compound, usually an organic such as a hydrocarbon or alcohol, reacts with oxygen gas, and this will produce carbon dioxide gas and water. And so examples of this would be taking butane, reacting with oxygen, and making the carbon dioxide and water. Or we can take something like this butanol, react it with oxygen to form carbon dioxide and water. And so if you want to try and work on these, you can try to write the balanced equations for the combustion of propane, of hexane, and methanol. Like I said, in the next video, I'm going to go in quite a bit more detail about how to balance these types of reactions, but if you want to work on these, I would encourage you to do so. For balancing these, what we want to do, we'll start with our propane. We would end up with this right here, where we see we have 3 carbons here, so we should have 3 carbons right here. We have 8 hydrogens here, so we should have 2 times 4 right here, so that's 8 hydrogens there. We have 6 oxygens plus 4 oxygens, so that should be 10 oxygens, so 5 times 2 right here gives us our 10 oxygens. If we do the same thing for our hexane, we now end up with a 2 in front of it, and so these ones are 12 and 14, and then 19 oxygens. Again, I will go into a lot more detail about how to do this in the next video, but if you were trying to balance these on your own, this is the answer you should have gotten. Then for the methanol, we end up with this, so again, a 2 in front of the methanol, 2 in front of the carbon dioxide, 4 in front of the water, and 3 in front of the oxygen. Now, if you want to try working on these practice problems here, again, I would encourage you, pause the video and try these. So I'm not going to go into much detail about how to balance these, but I will give the answers. So we want to predict the type of reaction and then balance the chemical equation. So for the first one, we have calcium plus oxygen becoming calcium oxide. We need to put 2's in front of the calcium and a calcium oxide, and this would be a combination. We have 2 things, we're bringing them together to make 1 thing. The next one, we have this copper 2 chloride plus sodium sulfide becoming copper 2 sulfide plus sodium chloride. And so this one, we need to put a 2 in front of the sodium chloride, and this would be a double replacement, where again we see we're just switching the things that the different ions are bound to. And the other thing to notice about these kind is that we always have to have the positive going with the negative. So we couldn't have had the copper and the sodium over here in the products. It always has to be the positive and negative charge ions becoming bound together. The next one, we have hydroiodic acid plus bromine becoming hydrobromic acid plus iodine. And for this one, we need to put a 2 in front of the hydroiodic acid and the hydrobromic acid. And this would be a single replacement here, where again, we see one of the things that is kind of a hallmark of single replacement. We're taking something in this elemental form and replacing something that's in a compound with the thing in the elemental form. So the bromine here is replacing the iodine and becoming the hydrobromic acid. The next one, we have this phosphorus pentachloride becoming phosphorus trichloride and chlorine. We see that we have 5 chlorides in the reactants and in the products, 1 phosphorus in the reactants, 1 in the products, so that one is already balanced. But this would be a decomposition, where we have 1 thing becoming 2 things here. The one below that, we have a hydrocarbon plus oxygen becoming carbon dioxide plus water. That is the hallmark of a combustion reaction, and so we would just need to balance this, and so we would end up with this. and that would be a combustion reaction. But anyway, I hope you found this video helpful, and I will see you in the next one.